Okay. Good evening, everyone. Today. Okay. Today we are going to discuss about measuring instrument practicals, as we discussed earlier. And today I have sent two tubes to another additional tubes today. One is about micrometer screw gauge. Other one is about spherometer. I will send the hard copies of those tubes within this month today. So I have to send another tube regarding force equilibrium. With that tube, I will send the balance of tubes within this month. So there is this one package for them. And so if anyone need the hard copies of previous tubes, please let me know. I will send that too. And so most probably this month tubes will be delivered in next week. Next week means most probably next Monday or Tuesday. Next Monday or Tuesday, I can post those tubes today. So within the next week, you will be delivered those tubes. So as we discussed, today we are going to discuss about micrometer screw gauge as well as spherometer. Okay. Shall we move the lesson? Because today we have to cover two measuring instruments. Therefore, I will directly go to the lesson today. And at the point of telling lesson again. Okay. So micrometer screw gauge as well as spherometer are based on some special principle. That principle is called the screw principle. The screw principle. The screw principle. What is that? The screw principle means you know about screw, no? Screw nuts and screwdrivers, no? You know that one, no? So this is a screw. And so if you want to tight this screw, you have to use a screwdriver, no? So also, if you want to tight this screw nut, you have to rotate this screwdriver into which direction? Into which direction? If you want to tight means you have to drive this screw nut in forward direction. Put it right. Okay. Once you suppose this is a ball, yeah. Suppose this is a ball. Okay. Suppose this is a ball. So if you want to tight this screw nut into the wall, you have to rotate this screw. You have to rotate this screw in clockwise direction. You have to rotate this screw in clockwise direction. Once you rotate this screw in clockwise direction, this screw moves into the wall. Into the wall means it moves in forward direction. So if you want to lose this screw, you have to rotate in anti-clockwise direction. If you rotate in anti-clockwise direction, it will remove from the wall putty. And that means it moves backward direction. Therefore, if you rotate a screw in clockwise direction, it will move forward. If you rotate a screw in anti-clockwise direction, it will rotate. It will go into the backward direction. So this is a normal standard method. Okay. So this can be changed. This can be changed according to the instrument, but this is the standard way. This is the standard method of screw. And so this method is utilized to make some measuring instrument. How to do that? So that is called as screw principle. The method behind that is called the screw principle. Okay, we can learn that principle. Yeah? Okay. Shall I draw a screw? Have a screw? So this is. Okay. Okay. This is a screw with it. You know, in a screw, these are called as threads. Those are called as threads with it. Okay. So, in this screw, this one is called the head. This one is called the head. This is the tip put it. So this is the part of a screw. Okay. So there's a special principle behind a screw. What is that? You know the gap between these two. Normally, the gap between two consecutive threads is a constant. Throughout the screw, it is a constant. The gap between two consecutive threads, the gap between two consecutive threads is a constant throughout the screw. That is a normal standard way. That is a standard way. Right? So, this gap is a constant throughout a screw. Normally, a screw is made out of such a way when the screw head is rotated full circle. If the screw head is rotated a full circle, this screw moves this much of distance. This much of distance. Distance means this distance. Suppose this distance is d. Where once the screw head is rotated one full circle, that means 360 degree, this screw moves forward or backward direction. It can be moved in forward or backward direction, which is the distance equal to simple d. Okay. And therefore, this distance is called as pitch. This distance is called as pitch. Pitch means it is the distance between two consecutive threads. It is the distance between two consecutive threads. If I rotate a screw, if I rotate the screw head one circle, one full circle, the screw moves this much of length, either in backward or forward or backward direction. And then backward or forward direction, it can be moved this much of distance. And so this is the principle behind a screw. This is called the screw principle. So what is the principle behind a screw? If a screw rotate, if a screw is rotated full circle, if a screw is rotated full circle, it will move this much of distance. This much of distance means the distance equal to the pitch of the screw, either forward or backward direction. And okay, so this one is called pitch. Pitch means it is the distance between two consecutive threads. And did you get my point?
Yeah, sir.
Good. Alright. Then write a topic. The screw principle. The screw principle. This is the topic. Then you can draw this image. Okay.
Done, sir.
Okay. Thank you for that. Right under this. A screw can be rotated, either in clockwise or anti-clockwise directions. Either in clockwise or anti-clockwise directions. Based on the rotating direction, based on the rotating direction, based on the rotating direction, it moves either in forward or backward directions. It moves either in forward or backward directions. Pattern on that. Pattern on that. The distance between two consecutive threads is known as the pitch. Underline that word. Is known as the pitch. Underline that word. Pattern on that. When a screw is rotated, when a screw is rotated, a full round of 360 degree. A full round of 360 degree. When a screw is rotated, a full round of 360 degree, it moves a distance equal to its pitch. A distance equal to its pitch. A distance equal to its pitch. Okay, with it. So, what does that mean? So that means if this screw is rotated a full circle, it moves a distance equal to its pitch. And so if I rotate half circle, then how much distance may the screw move? If I rotate a half circle, then what will happen? If I rotate a full circle, if I rotate a full circle, then this screw is this screw moves x distance. X distance means it is equal to pitch. So my question is, if I rotate this screw a half round, then what is the distance?
Half feet. half pitch.
Yes, it should be half pitch or pitch over 2. So if I rotate this screw 1/4 round, that means quarter round. Then how
Quarter
long?
pitch.
Hmm?
Quarter pitch, sir.
Quarter pitch, quarter pitch. Okay. Therefore, the distance, which is traveled by this screw depends on the amount of rotation, the amount of rotation. So if I rotate a full circle, then it moves d distance. If I rotate 2 circles, then it will move 2d distance. If I rotate 3 circles, then it will move 3d distance. If I rotate half circle, then it will move d over 2 distance. Therefore, the traveling or moving distance or traveling distance of this tip depends on the amount of rotation, And screwdriver करते हो रहा है वो लगते हैं कावल दे कावल दे पढ़ते कावल तो कुछ okay हर अब एक लिया करते so you can write the this thing write another write in a new column new paragraph therefore the moving distance of a screw depends on the amount of rotation. Okay. Now here amount of rotation. Then the next column distance moved. Okay. Suppose if I rotate one full circle. So if I rotate one full circle, that means one round. If I rotate one round, then the distance move is equal to one pitch. Suppose this one is x. So if I rotate two rounds, definitely the moving distance should be equal to x. If I rotate 3 rounds, then moving distance 3x. So if I rotate half round, moving distance is x over 2. So if I rotate 1 over 10 rounds, the moving distance is x over 10. So if I rotate 1 over 50 rounds, that means 1 over 50 rounds, the moving distance should be equal to x over 50. So 50. And okay, try this table.
Done, sir.
Okay. This scenario, actually, this scenario can be developed as a measuring instrument. How to develop? How to develop this scenario as a measuring instrument? Hmm? Look at this one. Suppose this is a flat horizontal plane. And now there is a screw. Now there is a screw. And, okay. So, and suppose there's a small plate here. This is a plate. So if you want to measure the thickness of this plate, if you want to measure the thickness of this plate, you can do something. Huh? You know this is a screw, Nabute. You know this is a screw. So if you rotate this screw into the upward direction, and then you can put this plate in between this surface and the screw. And so if you know the number of rotation, the number of rotation that you have rotated of this screw, then you know how much distance may move by this screw. And so this principle can be developed as a measuring instrument, no? And so you can initially you can place this screw in a flat surface. Then you can place whatever the instrument, whatever the material, whatever the whatever the material that you want to measure in between this screw and the flat surface. Then you can move this screw into the upward direction by rotating. So once you, if you can count the number of rotation, if you can count the number of rotation until the surface, so if you can count the number of rotation until the tip comes to this location, then you know how much distance is traveled by this screw in upward direction. Then from that you can measure the thickness of this plate. The thickness of this plate is equal to the distance traveled by this screw. Did you get my point? Did you get my argument? Pehla argument hai? Everyone, I need the other responses.
Yes, sir.
Yeah, sir.
Thank you. Others? I need responses from everyone. If you want to clarify, I will repeat it. Okay. Thank you. Okay, we can write down that. I write this today. I run this table. This scenario can be developed can be developed as a measuring instrument. This scenario can be developed as a measuring instrument. Okay. Draw this one. Okay, I will repeat it. I will explain it again. Look at this one. Suppose now we have, so my objective is to develop this screw as a measuring instrument. And so when a screw is rotated, it moves either in upward or downward direction, or forward or backward direction. And so that scenario can be developed as a measuring instrument. And if a screw is rotated by one round, it moves a distance which is equal to its pitch, and if the screw is rotated by two rounds, it moves two times pitch. Therefore, that concept can be developed as a measuring instrument. Okay, so suppose now there is a flat surface. So on the surface there is a plate. You need to get the thickness of that plate. And suppose now there is a screw here. Now, so if you can rotate this screw, so if you can rotate this screw in upward direction, and if you can place this tip on the top of this plate, so until this distance you can measure how many rounds are rotated. So using that, you can determine, or you can calculate how many distance is moved by this screw, because one rotation is equal to pitch. Pitch means x. Suppose it is x. One rotation is equal to x. 2 rotation is equal to x. Suppose you have rotated 2.5 rotation. 2.5 rotation means this distance, this move distance should be equal to 2.5 times x. Did you get my point? Fine. Therefore, this method can be developed as a measuring instrument. Another good thing. Fair now? Okay. Right under this figure. Suppose we need to determine the thickness of a plate. We need to determine the thickness of a plate which is placed on a flat horizontal table. Suppose we need to determine the thickness of a plate which is placed on a flat horizontal table.
So which is placed on a
flat horizontal table. This can be measured. Using a screw. We know that a screw is rotated. We know that a screw is rotated. We know that if a screw is rotated, we know that if a screw is rotated, it will move either in upward or downward direction. Either in upward or downward directions. The distance traveled by the screw, can be determined can be determined by the number of rotation, by the number of rotations, by the number of rotations by the number of rotations. Right on that, right on that. Therefore, if we rotate this screw, if we rotate this screw, if we rotate this screw until the tip of the screw, until the tip of the screw until the tip of the screw touch the top surface of the plate, the top surface of the plate. And and take the number of rotations. Take the number of rotations. Then we can find, then we can find the distance traveled by the screw. The distance traveled by the screw. That is equal to the thickness of this plate. That is equal to the thickness of this plate. Right. එයාලා පොඩ්ඩක් වැඩි අමාරු නේද අපිට හැම වෙලේම number of මේ rotations count කර කර ඉන්න බෑනේ. No. Okay. But we cannot count the number of rotations every time නේ පුතේ. හරි. Therefore definitely there should be some standard procedure or some standard method to measure that travel distance. Therefore now we are going to incorporate a scale to this instrument. In this instrument, there are two movements within this instrument. Actually, there are two movements within this instrument. One is rotation. One is rotation. Okay. The head of the screw. The head of the screw is rotating, while the tip of the screw moves in a linear motion. And it moves in a linear direction. That means upward or downward or either in backward or forward. Anyway, the tip moves in a linear direction while the head moves around a circle. Therefore, this instrument or this mechanism has two rotation. One is a rotate, one is a has two movement, has two movements. One is a rotation, other one is a linear motion. Okay. Therefore, if you are going to use a scale, you have to measure both of those movements. You have to measure both of these movements. Therefore, we have to use two separate readings, two separate scales to measure the movements of two rotation. Okay. Did you get my point? Now we are going to make a scale. Now we are going to make a scale for this instrument, Putin. And so when we are going to make a scale, now we can understand there are two motions in this instrument. One is the head. What is the head? It moves in a circular path. It moves in a circular path. Other one is the tip. It moves in a linear path. Therefore, definitely those two motions should be measured. So to measure those two motions, definitely should have two separate scales. Did you get my point? Hmm?
Yes, sir.
Yes, sir.
Okay. We can write down that thing, okay? So write in another paragraph, okay? So if you want to develop this as a measuring instrument, there should be scale. There should be scale. No, Dave. The reason is we don't know how much the angle may we rotate the circular scale. If it is a full circle, that can be measured. If it is a half circle, okay, anyway we can measure. But if we rotate some amount of angle, how to measure that? Hmm? Well, we cannot do it. Therefore, definitely there should be scale on the head putih. So from that, you can measure the amount of rotation. Okay? Did you get my point? Okay. Mm, What was my last sentence?
There should be a scale, sir.
There should be a scale. Right on that. If we consider a screw, we can identify two motions. We can identify two motions. First stomach body. Stomach adalah. The screw head rotates in a circular path. The next stomach. The screw moves linearly. The screw moves linearly. Okay, I will repeat it again. The screw moves linearly. The screw moves linear direction में जाना. The screw moves in a linear direction. The screw moves in a linear direction. Okay, I will repeat it again. If we consider a screw, it has two rotation. It has two movement. First stomach, the screw head, the screw head rotates in a circular path. The second stomach is the screw moves in a linear direction. Therefore, there should be scales. To measure both the moments. Therefore, there should be scales. To measure both moments. movements. Both movements. I will repeat again. I will repeat it again. Therefore, there should be scales to measure both movements. Okay. Hurry. Now we are going to attach a scale on the head of the screw. Okay, now it is a circle. It is a circle with the screw head is a circle. Therefore, we are going to attach a circular scale because we need to measure the amount of rotation. To measure the amount of rotation, definitely there should be a circular scale. Then we can understand how much may the screw is rotated. And therefore, there should be circular scale. There should be circular scale on the top of the screw head. Suppose now okay. Suppose I have divided this circle. I have divided this circle into 50 equal parts. Into 50 equal parts. Suppose I have divided this circle into 50 equal parts. Okay. One up to 50 equal parts. That means the screw head is divided into 50 equal parts. That means if I rotate 50 parts, then there's a full circle. Okay? If I rotate 50 parts, then that means it is a full circle. And so if I rotate one part, that means it is a 150 of a circle, 150 of full round. And so if I rotate 20 parts, it means it is equal to 20 over 50 of full rotation. Did you get my point?
Yes, sir.
Okay, now I have divided this scale into 50 equal parts today. 50 equal parts. Suppose now here the threads. Okay. Let us assume the pitch is 10 millimeter. Pitch is equal 10 millimeter. And that means if 50 division is rotated, the amount of distance traveled by the screw is equal to 10 millimeter. So that means if 50 divisions. 50 divisions are rotated. The travel distance is equal. Travel distance is equal 10 millimeter. Did you get my point? I need attention from everyone.
Yes, sir.
Okay. Hello, Budhi. So that means if I rotate, I have marked 50 equal divisions in the on the head of the screw. That means if I rotate 50 marks, this screw moves 10 millimeter. 10 millimeter. Okay. Okay. Then that means if I rotate one division, if I rotate one division is rotated, then what is the traveling distance? What is the traveling distance? If one division is rotated, then what is the traveling distance? Yes, that is equal to 10 over 50. That means 1 over 5 millimeters. Did you make my point? For 50 divisions, traveling distance is 10. For 50 divisions, traveling distance is 10. Therefore, for one division, traveling distance should be equal to 10 over 50. 10 over 50, that means 1 over 5. 1 over 5 millimeter. And 1 over 5 means it is equal to 0.02 millimeter. Did you get my point? Everyone, I need your responses. We need the amount. මට මේක අනිවාර්යෙන් පැහැදිලි කරගන්න ඕනේ පුතේ. කාට හරි පැහැදිලි නම් මට කියන්න. හරි. ඒ කියන්නේ මම මේ හෙඩ් එක මොකද්ද මේ ස්ක්‍රූ හෙඩ් එක මම ඩිවයිඩ් කරගත්තා ඩිවිෂන්ස් මේ 50 ඩිවිෂන්ස් වලට. හරිද? ඒ කියන්නේ ෆුල් සර්කල් එකක් equal 50 divisions. හරිද? එතකොට මම ෆුල් සර්කල් එකක් කරකවනවා කියලා කියන්නේ 50 divisions කරකවනවා කියලා. මම දන්නා ෆුල් සර්කල් එකක් කරගොත් පිච් එකක් යනවානේ පුතේ. එහෙනම් 50 divisions කරකෙවුවොත් එම අනිවාර්යෙන් පිච් එක ගන්නට යන්න ඕන. හරිද? 0.2 හරි. sorry 0.2 0.0 not 0.2 0.2 0.2 0.2 හරි. හරි. ඒ කියන්නේ මෙයා 50 divisions කරකෙවුවොත් 10 millimeter යන්න ඕන. හරි. ඒ වගේ පුතේ එහෙමනම් මෙයා එක ඩිවිෂන් එකක් කරකවුවොත් යන්න ඕනේ අනිවාර්යෙන් අරකින් 1 over 50 ප්‍රමාණයක් තමයි යන්න ඕනේ. ඒ කියන්නේ 10 out of 50. And okay, that means 0.2 millimeters. And so that should be the least measurable distance. No, because I have divided this scale into 50 divisions. Therefore, I can read only those divisions. So this length is the minimum measurable distance from this measuring instrument. Did you get my point?
Yes, sir.
So this is called the least count. So how did I measure the least count? This is the pitch. This is the number of division in the circular division, circular scale. That means this is the number of divisions in the screw head. This is the pitch. Therefore, if it is a if it is an instrument made out of screw principle, the least count is equal to the pitch over number of divisions in the circular scale. Did you get my point? පැහැදිලිද මේක least count එක කියලා? මීට වඩා පොඩි distance යන්න පුළුවන් නමුත් measure කරන්න බෑනේ පුතේ. Least count means it is the minimum measurable amount පුතේ. It is the minimum measurable amount. And therefore, this is the minimum measurable amount from this instrument. හැමෝටම තේරුණාද? හරිද? Himasha, හරිද පුතේ?
Yes, sir.
Okay, others? Sasit? හරිද පුතේ? Yugara? Okay. හරි. Okay. හරි. අපි ඒක දාගමු පුතේ. Okay. Right under this.
So do you ask to draw this?
No. I will give you time, okay? We can write on this, We can attach a circular scale. We can attach a circular scale. On the circuit, sorry, we can attach a circular scale on the screw head. On the screw head, we can attach a circular scale on the screw head. And divide it into equal divisions. Let assume there are 50 equal divisions. Let's assume there are 50 equal divisions. On the screw head of a screw. On the screw head of a screw. And the pitch is 10 millimeters. 10 millimeter. Okay, now you can do this. Chal.
Done, sir.
Okay. Write on this figure. Write on this figure. Therefore, if we move, sorry, if we rotate, therefore, if we rotate, 50 divisions, if we rotate 50 divisions, if we rotate 50 divisions, then the screw moves 10 millimeter. The screw moves 10 millimeters. That means 50 millimeter division equal 10 millimeter movement putting. So one division rotation is equal to 10 over 50 millimeter movement. Okay. So this amount should be the least, or this is the minimum measurable value through this instrument putting. And ඊට වඩා අඩු ඒවා තියෙන්න පුළුවන් measurable and measurable කි මෙච්චර මොකක් අපිට තියෙන scale එකක් කොහොමද හරි try this one clear.
Done, sir.
Okay. Right. Okay, write on that. Write on this. So this is the smallest. This is the smallest measurable value. This should be. So this should be the smallest. So this is the smallest measurable value that can be taken by this instrument. That can be taken by this instrument. Therefore, this should be the least count of this instrument. Therefore, this should be the least count of this instrument. Okay, clear our topic. Clear our topic. Least count of an instrument based on the screw principle. You understand? Therefore, pitch is equal to x. Done.
Done, sir.
Also, draw this figure, please write these two sentences. Okay, write on this, write on this. Therefore, distance moved by the screw. Therefore, distance moved by the screw. When it rotates, when it is rotated by a full circle. By a full circle of n divisions. Is equal to the x. Therefore, distance moved by the screw when it is rotated by a full circle of n divisions. Simple full circles of simple n divisions. Is equal to x. Therefore, distance moved by the screw when it is rotated by one division is equal to the x over n. And for n division, the move distance is x. Therefore, for one division, x over n. Therefore, the least count. Therefore, the least count is equal x over n. X over n. X means pitch to the. This is pitch. N means number of divisions in circular scale. In circular scale. And therefore, this is the method of calculating the least count in a screw principle. And so, how to calculate how to calculate this count? You have to get the ratio between the pitch and number of divisions in the circular scale. Do you have any questions regarding the screw principle? So this is the screw principle. Then we are going to discuss about some measuring instrument, actually, micrometer, screw gauge, and the spherometer, which are made out of which are made based on this principle. And so after this, we are going to discuss those two instruments. And so before going to that part, if you have anything to clear, please let me know. No. Captain Morgan. Okay. How to calculate this count? It is equal to pitch over number of divisions. Pitch over number of divisions. Once you complete it, please let me know. Then write an example. Example number 1. Suppose there's a screw gauge. There's a screw gauge. There's a screw gauge. With a circular scale. So there's a screw gauge with a circular scale that having 100 equal division. 100 equal divisions. Suppose there's a screw gauge that having a circular scale. Sorry. So there's a screw gauge with a circular scale that having 100 equal divisions. I will repeat it again. Suppose there's a screw gauge with a circular scale that having 100 equal divisions. The pitch of the screw is 1 millimeter. The pitch of the screw is 1 millimeter. Calculate.
Sir, a picture of a screw.
Sorry,
A picture of a screw.
The pitch of the screw is 1 millimeter. 1 millimeter. Calculate the least count of the instrument. Calculate the least count of the instrument. Calculate the least count of the instrument. The second one, yeah, that is equal to that is equal to this count is equal to pitch over number of divisions in the circular scale. Number of divisions in circular scale. Here pitch is 1 millimeter. Number of divisions is equal to 100. Therefore, least count is equal to 0.01 millimeter. Okay. Then write another question. The screw in a screw gauge, moves the second question. The screw of a screw gauge moves 0.5 millimeter. 0.5 millimeters in one full circle. In one full circle. In one full circle. If there are 50 divisions, there are 50 divisions. If there are 50 divisions in the circular scale, in the circular scale, in the circular scale, find the least count of the instrument. Find the least count of the instrument. අදකට පොඩක් වෙනස් විදිහට තියලා තියෙන්නේ. කෙලිම පිච් එක කියලා නෑ. හැබැයි පිච් එක වෙන විදිහකට තියලා තියෙනවා නේ. කොහොමද තියලා තියෙන්නේ? full circle එකක් ගියොත් man distance එක තියලා තියෙනවා. Yeah. Therefore pitch is equal 0.5. Pitch is equal here pitch is equal 0.5 millimeters. Number of divisions. Number of divisions is equal to 50 divisions, no? It is equal to 50 divisions. Therefore, least count is equal 0.5 over 50. That means 0.01 millimeters. 0.01 millimeters. And okay. Now we have to do the micrometer stroke gauge and the spherometer. අපි ඒක පටන් ගන්න කලින් පොඩි break එකක් අරන් ඉමු. So you can take a break now. කීයදලා? We can take a 10 minutes break, okay? So not 10 minutes, 20 minutes, okay? 20 minutes coming. 20 minutes break. That means please come at 9:10. 9:10 in the morning. Okay with it. Shall I start? Continue the video. Okay. So we have discussed about screw principle. Screw principle. Now we are going to discuss about two instruments that I use. Actually, the screw principle is used in this instrument. Okay. The first instrument is micrometer screw gauge. Micrometer screw gauge. So, final topic, micrometer screw gauge. Micrometer screw gauge. Micrometer screw gauge. Okay. Here, this is something. This is a micrometer screw gauge. Okay. Actually, I have sent you the tube today. So in that tube, there is a figure. Therefore, no need to do this figure again. Have there are two tubes. There are two tubes. One is for micrometer screw gauge. Other one is for spherometer. And actually, there are some theoretical part to be discussed in micrometer screw gauge. So we have to write something in micrometer screw gauge, but for spherometer, no need to write anything because all are given in the tube. Okay. So I will send the hard copies. I will send the hard copies. Please. I think there are some new students here, new students. So if you need hard copies, please let me know. Please let me know. Okay. So we are not going to write all the things in our notebook because there are some theoretical part in our notebook. Correct? Wait.
Sir, could you please wait a minute so I could leave and rejoin?
Okay. Okay. What about others? Can you hear me clearly? Now I know how to do. Okay, sound again. What question?
No, sir. Can hear properly.
මම කතා කරගෙන හිටපු දේ අපි ටියුබ් එක ඕගොල්ලන්ට එවලා තියෙනවා. ටියුබ් එකේ තියරිටිකල් පාර්ට් එක තියෙනවා. ඒ ටික ආයෙසරක් මේක ලියන්න ඕනේ නැහැ. මම ඒක එව්වෙත් ඒකයි. මොකද ওই ටික කොහොම අපි නෝට්බුක් එකේ ලියන්නකොත් ගොඩක් ලොකු වෙලාවක් යනවා. හරිද? මොකද අපි ගත්තොත් එහෙම මේක සාමාන්‍යයෙන් අර අපිට මේ සාමාන්‍යයෙන් අපි ගත්තොත් එහෙම පොසිබිලිටි එකකින් ගත්තොත් එහෙම ටිකක් එහා තියෙන පොසිබිලිටි තියෙන දේවල් ටිකක්. ඒ නිසා ආයි මේකට ටයිම් කන්සියුම් කරන එක ලොකු තේරුමක් නැහැ. හැබැයි එහෙම කියලා අතාරින්න බෑ. ඒකම ඔක්කොම නෝට් එක ඕගලන්ට එව්වේ. හරිද? ඒක නිසා ඒකේ හાર્ඩ් කොපිස් ටික මම ඕගලන්ට එවනවා. මට කලින් මාගාව මං ගිය පාර එපු ළමයි ටිකට ආයසරයක් මං එහෙමම එවනවා. හරිද? හැබැයි ඊට අමතරව ඇඩ් වෙච්ච ළමයි ඉන්නවා. ඊට අමතරව ඇඩ් වෙච්ච ළමයි ඉන්න නිසා මට ඒගොල්ලන්ගේ ඇඩ්‍රසස් මට වෙනම එවන්න පර්සනලි අවශ්‍ය කට්ටිය. හරිද? ගිය පාර ආපු නැති ආය පාරක් ඕනින් කියලා හිතන කට්ටියට නම් ඒක තමයි එවන්න. මොකද next week එකේ මම මේ ටික පෝස්ට් කරනවා. හරිද? next week එකේ පෝස්ට් කරනවා. එතකොට next week එක ඕනන්න ගොඩක් වෙලාවට හම්බ වෙයි මේ ටියුට්ස් දෙකත් එක්ක. තව අපිට ටියුට් එකක් එනවා මේ මොනවද? error estimations වලට. error estimations වල ඊට පස්සේ මේ ඒකයි අපි වෙන්නේ කැලිපර් එකේ සාමාන්‍යයෙන් නෝට් එකේ තුන ටියුට් එකක් අපි වුණා. අපි මේ කරා මේ ඒකේ හાર્ඩ් කොපිස් එකයි ඊට පස්සේ ෆෝස් ඉක්විලිබියම් එකේ තියෙනකොට ෆෝස් ඉක්විලිබියම් එකේ ටියුට් එකේ හાર્ඩ් කොපිස් එකේ වුණා. හරිද? එතකොට අපිට මේ හાર્ඩ් කොපිස් තියෙනවා ඔක්කොම ටික ඊළඟට අපිට අර වෙක්ටර් එක තව ටියුට් එකක් තියෙනවා වෙක්ටර් එකේ තව ටියුට් එකක් තියෙනවා ඒක වන්න ඒක අතන පේපර් එකක් ඒ පේපර් එක ඔයගලන්ට එවන්න තියෙනවා හරිද ඔන්න ඔය කියන ටියුට්ස් ටික ඔයගොල්ලන්ට මේ මන්ත් එකේ හම්බ වෙනවා මේ මන්ත් එකේ ටියුට් ලිස්ට් එකේ ටික තියෙනවා හරිද මේ ඒක නිසා ඔයාලා ටියුට් රික්වෙස්ට් කරන කට්ටිය ටියුට් රික්වෙස්ට් කරන්න මේ කලින් පාර ටියුට් ඇවිල්ලා ආයෙසරක් ඔයගොල්ලන්ට ඕන්ලයින් එකේ දුන්නා ඒත් මම කියන්නේ එතකොට ඒක නිසා පැහැදිලිව කලින් ආපු ලිස්ට් එක එහෙමම මම මේන්ටේන් කරනවා. ඒ නිසා දැන් ඕගොල්ලෝ දන්නවනේ කාටද ආපු කියලා. ඔයාට ආවේ නැත්නම් සහ ඔයාට කරගන්න ඕන නම් වගේ නම මේ මට එවන්න ඇඩ්‍රස් එකත් එක්ක. හරි. Shall we continue? Okay. Okay. Now we are going to discuss two instruments. One is micrometer screw gauge. Actually, this is the micrometer screw gauge. And now, in this micrometer screw gauge, you can clearly see this part. Okay. This part. This one. This one is called as spindle. 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 Okay. Actually, this is the screw. This is the screw inside this instrument. We cannot see the screw, but this is the screw. Take a So this is the screw inside this instrument, and therefore is spindle. We call it as a spindle. Sorry, a spindle contains a screw inside it. And therefore, there is a screw inside the spindle. So this is the screw part of the instrument. And okay. So most important thing is you have to name. You have to name the parts of this instrument. And that is the most important thing. And මට මෙතන එකක් අවශ්‍ය කරා මෙතන මේ අපේ ලොකින් සිස්ටම් එක තියෙනවා. Okay. Today, you have to name, you have to clearly understand what are the components of this instrument, and you should have this ability. And that means you have to have ability to name each and every components of this instrument. And you have to have very good understanding what are the usage of those components. And my tutor, usage is බලන්න පුතේ. මම මේක පොඩ්ඩක් අල්ලලා පෙන්නන්නම්. So this is called micrometer screw gauge. This is called micrometer screw gauge. Okay, there are some main parts with it. And this part, look at this one. This is the stationary part with it. This is the stationary part. This one is called anvil. Anvil. And අපි මේක කියන්නේ anvil කියලා. So anvil එක තියෙන්නේ කාට කෙලින්ම මේ spindle එක ගිහිල්ලා වදින්නේ. මේ spindle එක ගිහිල්ලා වදින්නේ anvil එක. And we can stop this spindle at the anvil. Spindle එක එතනට තමයි set වෙන්නේ. And so this is called anvil. This is the spindle. Spindle. And okay, you can clearly see this part with it. This part. Look at this part. I'll make close and photos here. This part. Here, there's a scale with it. This scale is called the linear scale. Linear scale. Make up a linear scale like again. Okay? Linear scale. This is the linear scale. So linear scale is marked on the sleeve. We call this unit as sleeve. So the linear scale is marked on the sleeve. Therefore, this is called sleeve. Linear scale. Here there's this. Here there's the circular scale. Okay, circular scale. This is the circular scale. circular scale. And this part, you can clearly see this part. This is a rough surface. This is a rough surface. So when you rotate the micrometer screw gauge, you have to put your finger. You have to put your finger here, and then you can rotate the micrometer screw gauge. That means you can create. Sorry, you can move the spindle in forward direction or backward direction by rotating this part. Okay, so this part is called the thimble. Okay, so when you are rotating the micrometer screw gauge, do not touch from here. Okay, you have to touch from here. It is very clear. There's a rough surface here. There's a rough surface here. So you have to put your finger here. Don't put your fingers here because there's a scale. There's a scale. There's a scale here. So once you touch from your finger, after some time, they can be erased, and therefore don't touch the micrometer screw gauge from here. You have to touch, or you have to hold the micrometer screw gauge from this rough surface. Okay, so this rough surface is called the thimble. Thimble. It is called the thimble. Thimble. And this is small gadget is called thimble head or ratchet. Thimble head or ratchet. Ratchet. Okay. Then another thing. This is called it is holding a screw. Ratchet. Ratchet. Ah, okay. So those are components of micrometer screw gauge. Actually, those names are not very much familiar to you. I know that one. Therefore, you have to remember those names today. Therefore, it is better to draw this figure, draw this image on your book and mark them. Take a mark කරගන්න නැත්නම් ඔක අමතක කරනවා. මට ඒක ටියුට් එක දුරට ගමන් එක mark කරගන්න. Okay. They write a topic micrometer screw gauge. Write a topic micrometer screw gauge. Then draw this image and mark them. Omega, and then put it. Do this one. Okay. Topic is micrometer screw gauge. Then draw this. Okay. Very good.
Done, sir.
Got it. Okay. Shall we discuss what are the main objectives of each and every component of this instrument? We can start from here. And those are mentioned in our tube, therefore no need to write, but you have to listen to it. Anvil and spindle. Actually, when you are placing an object, when you are placing an object, you have to place that object in between anvil and the spindle. Therefore, anvil act as a stationary surface to hold that kind of object. And therefore, anvil actually act as a stationary surface to hold an object that object that we need to measure. Then spindle, you know the spindle. Spindle is the screw within this instrument. Therefore, this is used to measure the length. And the length measure spindle. So this is the screw within this instrument. Then lock nut. Lock nut means this one. Lock nut or holding mechanism is this one. So once you press the lock nut, you cannot rotate it. Press rotate. Once you press the lock nut, you cannot rotate with it. You cannot rotate it. Rotate. That means when you take in a reading, you have to press the lock nut. Then you can keep that reading as it is until you may take the reading. Okay, otherwise reading can be changed with the change. Therefore, to hold the reading until you take that, you have to press the lock nut. That is the purpose of lock nut. Then sleeve. Sleeve means it is the linear scale. Therefore, sleeve is used to mark the linear scale. Normally, this scale is in 0.5 millimeters per day. And 0.5 millimeters. That means okay, 0.5 millimeters. That means from here to here 1 millimeter. From here to here 1 millimeter. 1 millimeter. Let me see. If this one is 0, this one is 1, 2, 3, like that. And so in between these two consecutive marks, there's another mark. So that should be 0.5 mark. Therefore, This mark is 0.5. This mark is 1.5. This mark is 2.5. This mark is 3.5. That is not mentioned. That is not mentioned numerically on the sleeve puthi. But it is in the middle. It is in the middle in between 0 and 1. Therefore, this is the 0.5 mark. Therefore, in normal micrometer gauge, the linear scale is scale 0.5 millimeters in 0.5 millimeters. Okay. ඒක 0.5 millimeters mark කරලා තියෙනෙත් මොකද බොහොම ලස්සනද මම කිව්වා වගේ ඒක ඇත්තටම මේ 1 millimeters වලින්ම තමයි mark කරලා තියෙන්නේ. හැබැයි මෙයා start කරලා තියෙන්නේ middle එකේ. හරි. එතකොට මෙයා middle එකෙන් start කරන්න විතරයි ඕනේ. middle එකෙන් start කරලා 1 millimeters වලින්ම තිබ්බනම් වැඩි. හරි. හරි. ඒ නිසා සාමාන්‍ය මේ ඉලක්කම වැටෙන්නේ නැහැ. උඩ ඉලක්කම විතරයි වැටෙන්නේ. මේ ඉලක්කම තියෙන්නේ මැද. එතකොට අපි දැනගන්න ඕනේ ඒක 0.5 millimeter mark කියලා. Therefore, the usage of slave is it is used to mark the linear scale. Right. Then this part. This part. So in this part, actually, there are two parts for it. One is this smooth surface part, smooth part, and this smooth one contains the circular scale. You can say circular scale. Circular scale like a mark the smooth part. And then there's a rough surface. There's a rough surface that is used to hold the micrometer screw gauge when it is rotated. When it is rotation, you have to keep your finger here. And therefore, thimble is used to rotate the spindle. It is used to rotate the spindle into the upward or backward direction. From a forward or backward directions. And then, and therefore, this is circular path. Thimble is used to rotate the spindle backward or forward directions. And look at this one. Suppose you are going to hold an object. Suppose you are going to hold an object in between the anvil and the spindle. Okay, when you keep your object in between anvil and spindle, once you rotate this rotate the spindle, once you rotate the spindle using thimble, actually it moves in large scale. And that means sometimes this object can be pressed. It can be pressed. So if the object is pressed, then two things can be happen. The first one is, if it is pressed, then the reading might be changed little bit. So if it is a solid material, then may change is negligible. But if it is a rubber or something, then it can be changed. So if it is a small wire, it can be changed. Because if it is over tightening, our reading will be differ than the actual value. That is the number one. Other thing is, if I over tight this one, then our spindle and the anvil can be damaged. It can be damaged. Therefore, we have to avoid over tightening. We have to avoid over tightening. To avoid over tightening, there's a mechanism that is called thimble head or ratchet. So once you come closer to touch the object, you have to stop. You have to stop rotating using the thimble. Once you come closer, then you have to stop this rotating. Then you can rotate using the thimble head. Using the thimble head. Okay. And once you rotate thimble head, it moves in very small distance. It moves in very small distance. Okay. Once the object, once the spindle touch the object, then this thimble head rotates freely with it. It will not press the spindle. That is the most important thing here. And that is the most important thing here. Once the spindle touch the object, yeah, touch the spindle touch this will not push the thimble again. Not the spindle again. This will rotate freely. Okay, you can feel it. මේක ගන්නකොට තේරෙනවා. හරිද? මේක දැන් මෙහෙම දැන් මම rotate කරනකොට දැන් මේ rotate කරනකොට මගේ අත දැනනවා පුතේ මේක යනවා කියලා. මේක ඉස්සරහට යනවා කියලා දැනෙනවා. හරිද? ඒ වුණාට ඉතින් බලන්න දැන් බලන්න මේක touch කරනකොට දැන් බලන්න මේක touch කරනවා. දැන් මම මේක touch කරනවා. ඔන්න. touch කරලා මේක කරනකොට දැන් මට තේරෙනවා පුතේ මේක දැන් යන්නේ freely කියලා. Then make it free. You can feel it. Right? You can feel it. Once the spindle touch the object, then the thimble head or ratchet will not push the spindle. It will not push the spindle further. Then it will rotate freely. Therefore, you can use ratchet to overcome over-tightening. Over-tightening is not a good thing just because of that two reasons. Our reading may change from the actual one. Other thing, the spindle may surface and the new surface can be damaged. It can be damaged. Therefore, over-tightening is not good for reading as well as the instrument. Hi. So those are the main things that you have to know. Then normally the pitch of this screw is 0.5. And the pitch of this screw is 0.5 millimeter. There are 50 divisions. There are 50 divisions in the circular scale. There are 50 divisions in circular scale. Therefore, the least count of micrometer screw gauge is 0.01 millimeter. 0.01 millimeter. And therefore, you can measure up to 0.01 millimeter using micrometer screw gauge. You know, I think you can remember the least count of vernier caliper. How much that is? Least count of vernier caliper? Least count of vernier caliper? Yeah, Kunal, it's counting.
Simple n minus capital N divided by n.
No. That is a way of me finding the list count. I mean, so if it is a normal or general use vernier caliper, what would be the least count? Value. Yeah, 0.1. 0.1. That is the least count of a general or normal vernier caliper. Now, when it comes to a micrometer screw gauge, if it is a normal micrometer screw gauge, then the least count is 0.01, which is 10 times accurate than vernier caliper. That is 10 times accurate than vernier caliper. But the thing is, we can only measure the external measurements using micrometer screw gauge. By using vernier caliper, actually we can measure internal diameters and depth of hole as well as external measurements. But by using a micrometer screw gauge, we can only measure external measurements only. And because you have to place the object to be measured in between these two parts and will and spindle, and therefore you cannot measure other internal things using micrometer screw gauge method. Okay. අපි ඔන්න පොඩ්ඩක් ටික ලියාගමු. Write on this. No need to write everything because all the other things are mentioned in the tutorial. Generally, the linear scale mark on the sleeve is in 0.5 millimeters. Is in 0.5 millimeters. That means the pitch of the screw I will repeat it again. The linear scale, which is marked on the sleeve, in 0.5 millimeters. The linear scale which is marked on the sleeve is in is in 0.5 millimeters. That means the pitch of the screw is 0.5 millimeters. That means the pitch of the screw is 0.5 millimeters. Right on that. In this case, come on, the screw is arranged. The screw is arranged the screw is arranged inside the sleeve. Inside the sleeve. Inside the sleeve. మీకు అర్థమైన గుర్తు inside the sleeve. And the thimble, the thimble, the thimble the thimble is fitted. The thimble is fitted the thimble is fitted onto the back side of the screw. Onto the back side of the screw. The thimble is fitted onto the back side of the screw while the spindle while the spindle is fitted the spindle is fitted onto its front. Onto its front. That means there is a screw. The screw is inside this unit. It is inside this unit. And the front side of the screw is fitted to the spindle. The back side is fitted to the thimble. That is the reason when the thimble is rotated, spindle moves in upward or backward direction. And so that is the reason. Because the head of the screw is fitted to the spindle, while the tip of the screw is fitted to the thimble. This is spindle. The head of the screw is fitted to the thimble, while the tip of the screw is fitted to the spindle. And did you get my point? තේරෙනවද? මේක ඇතුළේ තියෙන ස්ක්‍රූ එකේ හෙඩ් එක උත මෙතනට එන්නේ. ටිප් එක මෙතනට යන්නේ. ඒක නිසා තමයි මේ හෙඩ් එක කරකවලකට පුතේ. ටිප් එක ඉස්සරහට පස්සට යන්නේ. අන්න ඒක නිසා තමයි ටිප් එක ඉස්සරහට පස්සට යන්නේ හෙඩ් එක කරකවලකට. Did you get my point? පැහැදිලිද?
Yes, sir.
හරි. Okay. Great. හරි. තව දෙයක් තියෙනවා ස්පෙෂල් දෙයක්. So guys, you can clearly see horizontal mark. Horizontal line there. Actually, this linear scale is marked on a horizontal line. It is marked on a horizontal line in either side. The linear scale is marked on this horizontal line. And actually, this horizontal line is marked to identify the overlap of zero marks in circular scale and the linear scale. And අපි ඒක use කරන්නේ පුතේ අපි zero marks දෙක overlap වුණාද නැද්ද කියලා identify කරගන්න. හරිද? Okay. You can write down that thing. Write in another paragraph. Write in another paragraph. There is a horizontal center line. There is a horizontal center line. In the linear scale, there's a horizontal center line in the linear scale. And it acts as a it acts as a reference line it acts as a reference line for the rotation of circular scale. For the rotation of circular scale. Right on that. Usually, the circular scale has 50 divisions. The circular scale has 50 divisions. 50 divisions. While the pitch is 0.5 millimeters. While the pitch is 0.5 millimeters. Therefore, the least count is equal to pitch over number of divisions. In circular scale. Therefore, least count is equal, pitch is 0.5 with a number of division is 50. So 0.01 millimeters. 0.01 millimeters. Sure. Hello. My photograph. Actually, when the spindle and anvil are touched. That means if we cross the micrometer screw gauge, then definitely the zero mark in the scale, circular scale. Zero mark in the circular scale should be coincided with the zero mark of the linear scale. And so in such cases, it's look like When the normally. And so when the annular and spindle touch each other, then the zero mark of the linear scale should be coincide with the zero mark made with the circular scale. Therefore, you can look like this. And maybe the linear scale, maybe the circular scale. Linear scale. This one is the circular scale. Okay. Write down this thing. When the spindle when the spindle is brought, when the spindle is brought into the contact with anvil, when the spindle is brought into the contact with anvil, the zero mark in the circular scale, the zero mark in the circular scale should be coincided, should be coincided should be coincided. Okay, I will repeat, I will repeat. I will repeat it again. When the spindle is brought into the contact, is brought into the contact with anvil, with anvil, the zero mark, the zero mark on the circular scale, on the circular scale, should be coincided with the zero mark, should be coincided with the zero mark the zero mark in the linear scale, in the linear scale. Okay. Now I can draw this one. Venga. Okay. Shall
Done, sir.
Okay, please let me know whether you can see this one. No,
Not clear, sir.
not clear, no? Not clear. Right. I will show the thing, okay? I will show the reading. Like reading about pen and on that back page, okay? Rotated direction का pen लिखना है
No.
No. Okay, I will say that. Okay, initially, this is the place of 0 mark. So this is the initial place of 0 mark. And so when you rotate, that means if you want to move this spindle in this direction, you have to rotate. You have to rotate it in downward direction. Okay? This is very important thing. Please listen to me very carefully. This is very important thing. Okay. So if you want to move the spindle in backward direction, that means if you want to make a gap, you have to rotate this one. You have to rotate this one in downward direction. Downward direction. It is very clear. It is very clear because 0 mark is in this side, this location. Then the 5 is in this location. 10 is in this location. Therefore, once you rotate in this, once you rotate the sleeve in downward direction, then the fifth division will come to this location. If you rotate further, then the 10th division will come to this location. Likewise, the number of divisions may increases. And so, most important thing is if you want to make a gap, or if you want to move the spindle in backward direction, you have to rotate the circular scale in downward direction. You have rotated in downward direction. Then this will be expanded. That means the linear scale will be open. Then you will have this kind of arrangement. So initially, you can see only 0 mark. But if you rotate this spindle in downward direction, then it will expand. This will expand. Therefore, now you can see this is 0 mark. Then 1, 2. Now you can see this one. Over here. So if you rotate in downward direction, then you can make a gap. Make a gap means the spindle moves in backward direction. Normally, before you take any reading, the micrometer screw gauge is at this position. That means both the spindle and anvil should be touch each other. So if you want to make a reading, then definitely you have to rotate the thimble in downward direction. Then you have to make a enough gap. Then you can insert your object, and then you can tight the thimble and the spindle. No, the thimble and the spindle, anvil and the spindle. And therefore, you have to have very good understanding about the rotation direction, the rotating direction of the circular motion. Okay, so circular scale. And so if the circular scale is rotated in downward direction, the spindle moves backward, then a gap will be formed. Then you can make a higher reading. That kind of things can be done. හරි තේරුම් ගන්න කියලා නේ හැම වෙලේම බලන්න නේ මෙයාව පල්ලහැරට කරපන්නේ මෙයාව පල්ලහැරට කරපන්නේ මෙයාව පල්ලහැරට කරපන්නේ you have to rotate this one, you have to rotate the thimble in downward direction, you have to rotate the thimble in downward direction. Okay, then you can make a gap, did you get my point? පැහැදිලිද
Yes, sir.
Okay, thank you. Hi. There are topic. Rotating direction of the circular scale. Rotating direction of the circular scale. Okay, please draw these two. First we have to draw this one, then make an arrow, mention final result. Once you rotate in downward direction, this will move in backward. This will move in backward direction. Okay, there I turn this. When the thimble is rotated, in downward direction, the spindle moves in backward direction. The spindle moves in backward direction. spindle moves in backward direction. Resulting an increase of the gap. An increase of the gap. Resulting an increase of the gap between the anvil and the spindle. Okay, suppose here now it has some value with it. You get me now, baby? Suppose there's a gap. Now there's a gap between the spindle and the anvil. Okay. So if you rotate this thimble in upward direction, what will happen? What will happen? You can clearly see the gap between two rods. That means the spindle and the anvil reduces, and after a while it will be zero. Therefore, the gap reduces. Therefore, if the thimble rotates in upward direction, then this one should move in backward direction. This one should move in backward direction. Once it moves into the backward direction, then it can become to this location. And so you have to draw this one first, then draw this one. Hello.
Done, sir.
Hello. They write down this thing. Write down on this. When the thimble is rotated in upward direction, when the thimble is rotated in upward direction, when the thimble is rotated in upward direction, the spindle moves in forward direction. The spindle moves in forward direction. Resulting clause in the gap. Resulting clause in the gap. Resulting clause in the gap between the spindle and the anvil. Start with. Okay. Do you have any questions up now? Do you have any questions up now?
No, sir, all clear.
No,
No,
answer
sir.
no. Thank you, Bhute. We are at topic. Now we are going to take readings for it. Third topic. Reading of a screw gauge. Reading of a screw gauge. Reading of a screw gauge. Okay. Okay. Look at this one. You know this thing. You know this scale. This scale is based on the pitch. That means the gap between two consecutive marks. The gap between two consecutive marks is this one. These are the two consecutive marks. The gap between two consecutive marks is equal to pitch. Is equal to pitch. That means it is a full rotation. It is a full rotation. So accordingly, I can say so from here to here, one rotation. Here to here, one rotation. Here to here, one. Again one. Again one. Again one. And again one. That means. Actually, you can read up to the last mark of the linear scale. That means up to that position, the circular motion is completed full circles. But After that, after this mark, there is no any other mark in the linear scale. That means still the circular motion, circular scale is not rotated fully after this mark. And therefore, from here to here, I can take the reading. From here to here, I can take the reading. It is equal to reading measured in the reading show in the linear scale. And because from here to here full circle, from here to here full circle, therefore this linear scale shows some integer number of pitch putin. And did you get my point? In linear scale, the gap between two consecutive marks is equal to pitch. Every time in linear scale, the gap between two consecutive marks is equal to pitch. That means it is a full circle. And therefore, from here to here, I know the move distance. I know the move distance because one gap is equal to pitch. Two gap means two pitch. Three gaps means three pitch. Therefore, this up to this level, up to this segment, I know the move distance. I know the move distance of this spring. That is equal to the reading of this scale, reading of this mark. Therefore, the first thing you have to do, take the maximum possible reading in the linear scale. It is the maximum possible reading in the linear scale plus this gap plus this gap. And cover the gap again. That gap can be determined using the least count and the coincide mark Okay. And suppose this mark is 5. If this mark is 5, so you have to multiply 5 with least count. You have to multiply that mark with least count. Then you will have this gap. The reading is equal. The reading of the microscope is equal maximum possible reading. In the main scale. That means you have to take the maximum possible reading in the main scale. So in this case, this is equal to 2.5 millimeters. This is equal to 2.5 because this one is 0.5 scale. 1, so 0, 1, 2. This one is 2.5. Therefore, maximum possible reading is 2.5. That is the number 1. You have to take the maximum possible reading in linear scale plus least count into the number of divisions, number of rotated divisions in circular scale. Number of rotated divisions in circular scale. And number of rotated division means you have to measure that thing. And because sometimes it's equal to the it is equal to the reading at this position, but sometimes you have to subtract that one from the 50. And I will let you know those cases. But the argument is something like this. Reading should be equal to maximum possible reading in the main scale plus come on. least count into the number of gaps. Number of gaps move. And ඔච්චර gap ප්‍රමාණයක් මම move වුණා. එච්චර බලන්න. එතකොට ඒක least count එක වැඩි කරාම අන්න මෙතන එනවා මේ total gap. අර විදිහම තමයි. අපි Vernier scale එකේ Vernier scale එකේ කොහොමද maximum possible reading එක ගත්තා. ඉතුරු gap එක ගත්ත කොහොමද? ඉතුරු gap එක ගත්තේ least count into the coincide length. Please count into the coincide length. So here you have to do the same thing. You have to take the maximum possible reading and least count into the coincide divisions. Coincide division means move divisions. කොච්චර division ප්‍රමාණයක් නම් move වුණාද කියලා. හා බලන්න. හරි. No, no. Zero means if it is zero, there should be a full circle, then definitely, if it is zero, then definitely that zero mark should be at here. It should be at here. මෙතනදී මැදදී zero mark එකක් කියන විදියක් නෑ කොහෙද? මැදදී zero mark එකක් එනවා නම් අර zero ඉරගත්ත පොත් වෙනවා. එහෙම නැත්නම් මැදදී zero mark එකක් කියන විදියක් නෑ. මොකද zero mark එකක් අනිවාර්යෙන් ඉන්නේ full circle එකක් කියන පස්සේ. ඒ නිසා ඔන්න මෙතනදී zero mark එක තියෙනවා. ඊට පස්සේ ආය zero mark එක කියන්නේ මෙතනදී. ආය zero mark එක නෑ මෙතනදී. ආය මෙතනදී. ඒ නිසා zero mark එක තිබ්බොත් තියෙන්නේ අනිවාර්යෙන් හරියටම මේ division එකක් ගානේ තමයි zero mark එකක් තියෙන්නේ. මොකද මේ division මෙතන තියෙන division එක equal වෙන අපුදේ full circle එක. හරි. ඒ නිසා full circle එක ගියට පස්සේ ආය zero වෙන්නේ මෙතන. තේරෙනවද මම කිව්වේ? පැහැදිලිද?
Yes, sir. Understood.
Then write the topic. Reading of a screw gauge. Reading of a screw gauge. Reading is equal to the maximum possible reading in linear scale plus least count into the coincide divisions. Practical scale. So this is the way of taking reading. Did you get this simply? තේරෙනවද මේක? කතේ තේරෙනවද?
Yes, sir.
හරි. දැන් අපි බලන්න ඕනේ පුතේ මේ coincided divisions ගන්න කොහොමද ගන්න කියලා. Now you have to consider how to determine the number of point the number of coincided divisions in the circular scale. Number of කොච්චර ගාණක් මෙතන මේ coincide වෙලා තියෙන්නේ. හරි. අන්න ඒක. බලමු කොහොමද ගන්න කියලා. Shall I erase this one?
Yes, sir.
Look at this one. You know, initially, the zero marks should be coincided like this. And then the divisions 5, here 5, here 10, 15 are into the upward direction, while 45, 40 are in downward direction. And so if you rotate this part in downward direction, definitely the smaller value should be the smaller values, that is 5, 10, 15 should be coincide with this linear zero mark. This linear zero mark. That means on the other hand, that means zero should be in downward direction. Yeah, you know the right. අපිට ඔක හදන්න පුළුවන් මේ කීපයකට. බලන්න. හිතන්න මේ 0 පල්ලෙහා හිටියා කියලා. 0 කියලා පල්ලෙහා හිටියා. 0 කියලා පල්ලෙහා හිටියොත් තියෙනවා. අන්න මෙයා 0 මාක් එකක් තියෙනවා. මේවට මොකද දැන් එන්න මට කියන්න දැන් 0 මාක් එක මෙතන තියෙනවා. දැන් මෙතන කියන්න දැන් එන්න මට කියන්න how many millimeters or how many gaps is rotated. දැන් කොච්චර ගානක් rotate වෙලා තියෙනවද මෙතන මේක. කොච්චර ගැප් ගන්න රොටේට් කරලා තියෙනවද? අන්න මේ කියන්නේ මම මෙයාර ඔක්කොම ටික ගන්නේ නැහැ මේ ඉරිකේල් ටික. Here there is no negative positive. Negative positive කියන්නේ පා gaps ගන්න මොනවද? How many gaps? 10 නේ. 10 gaps. හරි. මම මෙතන මේ පහෙන් පහ යන්නේ පුතේ මම මෙතන මෙතන ඉඳන් ඇතුළේ තියෙන ඉවැන්දේ නැහැ. මිලිමීටර් ස්කේල් එකේ මම ඔක්කොම ටික ගන්නේ නැහැ කරන්න බැරි නිසා පහෙන් පහ යන්නේ තකොට අනිවාර්යෙන් බලන්න ආර පැහැදිලිව මේ 0 එකට කලින් තිබෙ මෙතන 0. Initially the 0 level is at this position. Now we have rotated this one into downward direction. Now it comes to this location. And so 10th divisions come to the 0 level. That means it has rotated 10 number of divisions. It has rotated 10 number of divisions. It has rotated 10 number of divisions. So the least, if you multiply this division by least count, then you can get the reading of this part. Reading of this. There is first case. So in this case, number of gaps or number of divisions rotated is equal to 10. Therefore, the reading is equal to this count into 10. This count into 10. And number of divisions rotated is equal to 10. Therefore, reading is equal to 10 into this count. Okay. Now there is another case. Now 0 is in this line. Is still the rotation is downward direction. Is still the rotation is downward direction. And now tell me if the rotation is in downward direction. Now tell me what is the how many number of divisions are rotated? How many number of divisions are rotated in this case?
40.
40 or 10. I will plus minus නැහැ plus minus නැහැ. Number of divisions are yes, this is equal to 40, not 10. I මෙතන gap ගාලා මෙතන තිබ්බ කියලා 10 ගාලා ගන්න එපා. හරි. මෙයා උඩට එනවා කියලා කියන්නේ 40 ඒ කියන්නේ 40ක් පල්ලහැට යන්න ඕන. 40ක් පල්ලහැට ගියොත් මෙතන උඩට එනවා. And therefore the reading should be 40. The reading should be 40. The reading should be 40. Therefore, number of division rotated. Number of division rotated is 40. It is 40. And not 10. Okay, not 10. Number of divisions rotated is equal 40. Therefore, VD is equal 40 times LC is 40 times LC is and okay. You can do this example. The example can Oh. So what are the BP for that one? Okay. What is the reading here? Yeah, it is 20.
20.
Yes, it is 20. And it is 20. Therefore, in this case, reading is 20 to this count. 20 to this count. 20 to this count. Reading is 20. Please count it. And that means you have to take that value. That value is the number of division which is rotated. That value is the number of divisions which is rotated. Okay. I think that you can do some homework here. Question number 2. Question number 2 in the page 8. Page 8. Then page 9. Page 8 and page 9. In page 9, you have to fill the fill this one here. Sorry. Okay. Yeah. In question number 2, page 9. There are some examples. In that example, MSR mean main scale reading. MSR mean main scale reading. Mu SR means micro scale reading. That means it is the reading of it is that reading. That means it is a coincide mark with the reading scale. Main scale reading, micro scale reading. LC means count. Then RDG means reading. Okay. You can do the page number 8 and page number 9 as homework and send that to me. And the only thing you have to do is zero error. Have zero error විතරයි කරන් තියෙන්නේ. Zero error කරලා පස්සේ ඊට පස්සේ ස්පෙරෝමීටර් කරන් තියෙන්නේ. ස්පෙරෝමීටර් එක පොඩ්ඩක් කියවගෙන එන්න. ඊළඟට මම ඕගොල්ලන්ට වීඩියෝ එකක් දැම්ම ඒකත් පොඩ්ඩක් බලාගෙන ඉන්න. ස්පෙරෝමීටර් එක නම් එච්චර අමාරුවක් නැහැ. මොකද මේක මට පොඩ්ඩක් ඩිස්ක්‍රයිබ් කරන්න ඕනේ. මේක ඇතුළේ තාම උතේ බේසික් concept එක තියෙන්නේ. හරි. ඊට පස්සේ ස්පෙරෝමීටර් එක තියෙන්නේ මේකම තමයි. ඒ නිසා ලොකු දෙයක් නෑ ස්පෙරෝමීටර් එකේ. It work next time අපිට ඔය 0 error එකයි ස්පෙරෝමීටර් එකයි දෙකම complete කරන්න පුළුවන්. හරිද? Okay. So we can complete today's class today. Do you have any questions to ask?
No, sir, all clear.
Thank you. Hi. Okay, with it. Then thank you, everyone. Good night. Have a good day.
Thank you, sir. Good night. Take care.
Yeah, take care. Bye.
Good night, sir. Thank you, sir. Take care.
Have a good day.